Hey, this is Dr. Corey Glenn with Blue Sky Bio, and I wanted to show you a cool case that I'm working on. This is a technique that we're just now trying to start doing, and I'm working with Dr. Pavandeep Kaira, who's in the UK, places a lot of implants, and he's been doing this technique successfully, and so we're just trying to get together and hone in on the workflow to make this a little bit more accessible for people. But the idea is to use zirconia membranes, and so the same zirconia that you would mill your crowns and bridges out of, actually use that to create a membrane that's about zero point 0.5 to zero point 0.7 millimeters thick that will provide rigidity, protect the graft, no holes for bacteria and everything to come through, and then that also indexes onto the bone really well so that it's made ahead of time and you don't have to spend time shaping it. And so I'll go through the process of how we did this. To start the process, you're going to have a segmented jaw. When I say segmented jaw, I mean that you're going to have an STL model of the bone that's really accurate. If it's not an accurate STL, then your membrane is probably not going to fit. And so I do that by using the bone segmentation tools in Blue Sky Plan. So we're in the model editing module, and I'm going to go up here to panels, and this is under segmentation. And we're going to be doing advanced jaw segmentation. Now, if you've seen me do segmentation before, go ahead and skip a few minutes forward in this video to the point where we jump over to Mesh Mixer and you can see how the membrane's actually made. But first step is to indicate the jaw. We don't need to do the entire jaw here. We really only need to focus on the area in which the membrane is going to be done, and that's down here where this first molar is going to be removed, and try to accomplish some vertical and horizontal ridge augmentation. So just select that area, click Next, and as you can see, it's going to lead us through 9 slices here. So I'll start that by using the intelligent lasso. We're going to outline that, and then you'll have to fill in the gaps for the software where it misses things. So once you get a closed boundary all the way around it, you can now go to Fill Holes, and then you're ready to move to the next slice. But the idea is that you want to turn the entire slice of what is actually bone into this pink color. So now I'll click Next. I'll show you one more slice and then I'll begin time-lapsing it. Let's outline this. And now you could use the lasso again, close in the back edge, close in any areas where it missed the bone. And if you're going to err towards including more than you might think you need. So if you're looking at a little piece of something and you don't know for sure if that's bone or not, err towards including it. And now let's fill holes. And I do see that there's a little spot right there. And now click Next. So I'll go ahead and time lapse this. We'll repeat the same steps in the second half of segmentation, only on cross-sectional slices. Okay, so once you've performed the segmentation, I like to hit smooth one time, and then I'll go ahead and create a surface. So if I turn this into a different color, you'll see the outline of the chunk of bone that I've done. Now, I would like to capture a little bit beyond this, but I'd rather not have to do all that segmentation. And really, that's got such a great cortical boundary that I can pick up the rest of that by just coming down here in the CT surfaces on your surfaces panel and just push create model. Now, before I do that, I am going to cut away on the original CT all of the information that I don't really need, and so I don't need the maxilla. And I also don't need most of the anterior portion of the mandible, so I'm going to cut all of that away. And now you can see what I've still got remaining here. If I wanted to further isolate that, I could click Isolate and just click on the mandible. And now I'm going to push Create Model. Now that method also gives me another STL. So you see how I have 2 bone STLs up here? And if you were to look at the different model outlines on these, you're going to see that they do differ slightly. If I turn off the outline or the hint for the one that I just created by the density segmentation, where you just push the single button, that allows me to see the one that I've done purely by segmentation. So let's scroll through and look at this. And this is pretty good, but inevitably there's going to be some areas that you're going to miss, like right there. Now, why does the software miss that? I don't know, but the way you fix it, if you're doing it purely with segmentation, is to go back and add more slices in that area. However, if I was to now go and turn on the outline which was created by the Create Surface button, what you notice here is that this captured it. And so now let's turn the initial bone segmentation model off. And when I look at this, this does pretty good, especially in all the areas of dense cortical bone, but then there's areas of high porosity or little marrow spaces that the software just doesn't pick up. And so by combining the two of these, we kind of end up with the best of both worlds. We end up with a really solid watertight model with the greatest accuracy possible. And so I'll show you how I combine these in Mesh Mixer, but really at this point we're pretty much done in Blue Sky Plan. I'm going to go ahead and export these two STLs. So go to File, Export Data. And we want to export both of these and turn them into one STL. So both of them are checked on. I'll click Export. And I'm going to name this PAV Demo and save this to my desktop. And now I'll go to my desktop and open that up. And here you see that we now have this opened in Mesh Mixer. Okay, so for starters, what we need to do is combine these both into one solid watertight STL. Because remember, at the moment, it's a single STL of the jaw, but it's kind of composed of these two separate STLs just built together. Easy fix, just go to Edit, Make Solid. Now watch the accuracy change. You see that you lose some of the surface clarity. So we'll fix that by coming up here to Solid Type and change it to Accurate. Take your solid accuracy slider, slide it all the way to the maximum, and then I usually go about halfway with the mesh density, and let's update it now that we've increased those. And now you see you get a lot more of that surface clarity back, so I'm going to accept this. And then the next step is that we need to kind of wax this jaw up to the contours that we do want. So I'm going to start that process by removing the tooth that we know he's going to be getting rid of in surgery. And I'm going to just remove this crown of the other tooth just because of the scatter getting in my way. We'll just simply push delete on that. And then I'm going to also go down to a smaller select size. And this whole defect is going to get grafted, so we can really just go ahead and get rid of it all from the start. So now that that's separated, I can double click here and remove that tooth. Now, if we wanted to wax this jaw up to ideal, then obviously we need to fill in this big crater. So one of the ways in which I could do that is to come around here to the edges of where the bone contours are good and just highlight them. And just continue on right to the border of where that defect is. And with that done, I'm going to push delete. Okay. And I want to get rid of those little floating bits as well. So if I double click the jaw and then invert it, it will deselect the jaw and select those floating bits. Okay. So now we're ready to go ahead and try to close this in. And there's multiple ways you could do this. You could bridge across it. For example, if I was to go right here and select maybe the highest peak on the mesial and distal side, and then I could go to Edit and Bridge, and that's going to take this right across there. If I cancel that, another alternative that you could do is just use the select tool, and let's select right on this boundary. And now with that boundary selected, I could go to Edit, Erase, and Fill. Now this is a useful one because you can actually take this bulge slider, slide it to the right, and you'll be able to inflate that jaw up. So when he's doing this grafting, he'd like to overfill this a little bit, and that's going to hopefully help him gain more bone in the process. So that looks good. And then further, we're going to need to do a little lateral ridge augmentation in this area. So What I want to make sure that I don't do is I don't want to just randomly go around selecting all of this stuff and not know where the native parts of bone are that are going to remain unchanged, because those are the areas that this is going to have to index on. And so what I'll do to identify those is I'm going to go ahead with the selecting tool, and I'm going to go ahead and refine the or define the boundary of where this membrane is going to be. So I want to go a little beyond the defect, maybe a 5 mm perimeter. Probably don't need to go below the mylohyoid ridge. So we'll continue up and then back to where we started. And I'm going to create what's called a face group out of that. While it's selected here, I'm going to hit create face group. And I want to make sure that in this process, whatever I do, that I don't alter that, because I know that that blue area can be used as my boundary where the bone is going to be untouched, and thus if the membrane's made to seat on that, it should index itself in properly. Alright, so with that done, now we can start inflating the ridge a bit on the lateral side. So go to your brushes, go to the inflate tool, choose the appropriate size, that looks good. Choose the right strength, let's go maybe 3/4. And staying off of that blue area, what I'm going to do is begin bulking this up. Now you could just hold your left mouse button down and it'll inflate really quickly, but I think it's wiser to just take it a click at a time so that you have more control and you don't do too much at any one go. And that's exactly what I was referring to. You see how I overdid it right there because I didn't heed my own advice. So let's make that a bit smaller and inflate through this area. Now it's going to be a little rough, and that's fine because we're going to come back in and smooth that out. But I want it to be in the general contour. So that's bulked up pretty good. And now I'm going to use the brush tool and use the robust smooth on high strength and just go over all of those areas where I have inflated the jaw. And let's iron those out. Again, I'm maintaining a safe distance away from that blue area because I know that's going to be my area that I need to index this membrane on. And then I need to go a little smaller with the brush size so I can get down into this area. And there you have it. Now, you could do a better job on that, and I did on the actual case, but this being just a demo, we're going to proceed forward with this. So at this point, we're ready to make the membrane. And we want to make sure that it's going to seat right on this border. And so the reason I created the face group earlier is because now I can simply double click that as well as all of this internal surface, and that should reflect my membrane. Okay, let's start by smoothing the boundary. So optimize it first and then modify and smooth boundary. And there you see it. And now what I'll do is go to edit while this is selected, edit and offset. Now you need a little bit of a spacer between this. Even on the areas where it's going to sit directly on the bone, you really should want about a 0.2 offset to give you some freedom to get this thing fully seated without it binding, or if you had movement in the CT, this should account for that. So we've done that, and now it has created this second surface right here that's offset by 0.2 millimeters. You will need to come back at this point and smooth the boundary again. So I'll accept that. So now we have this membrane, but right now it's a one-dimensional object. So I need to first of all separate it. So I'll double click it all again, and I'm going to edit and separate. Now it's its own independent STL, but it's still not a 3D object. Okay, so there's a few different ways that you could now do this. You could extrude it However, the extruding on thin stuff like this tends to create a lot of little sharp triangles, and one of the better ways that I found of doing this is to actually come back in, double click all of this again, and offset it a second time. So edit and offset. All right, and this time offset it by whatever distance you want that membrane thickness to be. And so we're kind of playing around with this to see how thin we can mill this and still have good strength. But for the sake of this demonstration, let's go with 0.5. And let's accept that. Again, while this is still selected, come back in, modify, and smooth the boundary. That'll take out any of the little rough stuff that you see on here. And now we've got two separate skins, and what I'm going to do is turn the underside one inside out. Okay, so it's a bit hard to grab this. If I zoom in here you can see better, but if I double click that entire undersurface, now I can go to edit and flip normals, and now we're almost there. So I'll close this by just bridging a few areas. So let's bridge from right there to right here, edit, bridge. We'll continue on around the arch doing this, or around the membrane I should say. Edit, bridge. And now that we've bridged all those areas, these two surfaces that are offset from one another by 1 millimeter, now that I've closed these in, the software can go through the repair process and it will see these as individual holes and know what to join to what. So it's going to know to join this to this and close that hole. So now analysis, inspector, and let's just let the software repair all of these. And in this process of doing that, it's going to turn this back into a solid. Now this is an object that can actually be milled. Okay, so the last step in the process is you're going to have some areas to stabilize this membrane, and we're going to do that with some screws. Pav told me he's going to be using 1.2 millimeter screws, so I'm going to come into the mesh mix button and grab a cylinder and just drag it over here. And then using the uniform scaling, I'm going to drop the size of that down to 1.35. So it's 0.15 larger than what his screw is going to be. And then lengthwise, I can just lengthen it by grabbing that. And let's move this over into proximity with our membrane. And now just think about, surgical access in the mouth of how you want to position this. Let's come in, and on the buckle, it's probably going to be coming in at this kind of an angle. So it can be a little difficult to work with these and get them where you want them. But the good thing is that once I've positioned one of them where I want, and I'm going to do it right out here near that boundary where it's on the untouched bone surface, once I have one of those in place, the rest of them become very easy. So I could now edit and duplicate that, and you can't see it because it's sitting right under the first one. But if I hit transform, you can pull this off now and extend it back to where you want your next screw hole. All right. So for the sake of demonstration, let's only go with 2 here. I made several on the real case, but you would probably want to put one here, maybe one here. You just want to make sure that this is very well stabilized and it's not going to have any mobility during the healing process. So with that done, the last thing to do is to go ahead and create those screw holes by doing a Boolean subtraction of the pins that I've created, or the screws, from the membrane. So let's choose the membrane first. I've got it selected in the objects browser, and then holding Control, go and select the pin and then hit Boolean Difference. You can see that it's going to open that up, and then repeat the process with the next one. Boolean Difference. And what you now have is this zirconia membrane, which you'll be able to mill out, and will have the appropriate size screw holes. And when you go into the surgery, it's simply a matter of coming in and placing the graft in that area, and then just seating the membrane on top of it, screwing it down, and then getting primary closure, which is probably the most difficult portion of this procedure. It's just trying to get your flap edges closed on this. So I don't know how useful that is to very many people, but hopefully this is going to become something that's more commonplace, because I certainly see the benefits of this over things like titanium mesh membranes and things like that. So I hope you found that helpful.